Good morning to all. We are going to learn about Master's theorem, which comes under the second module. This is one method of solving a recurrence equations. Earlier we had solved the recurrence equation using recurrence tree as well as iterative method in the first module. This is second module. This is another method. There are three equations based on the value of the general form. How and where to substitute, we'll explain it. So, Master's theorem is a method of solving recurrence equation. It is directly gives us the cost of an algorithm. Recurrence equation is always of the form T of n is equal to a t n by b plus f of n. This is how a recurrence equation looks like. Now, here a is greater than or equal to 1, b should be greater than 1 and f of n should be greater than 0. N is the size of input, a is the number of sub-problems in that recursion. N by b is the size of each sub-problem. That is how many times it has to. If this is n by 2, that means t of n will be replaced by n by 2. If this a is 3, that means t of n will be having three different branches where it is substituted by n by b. Assume that all sub-problems have the same size. F of n is an asymptotically positive function. It is the cost of work done outside the recurrence call, which includes cost of dividing the problem and cost of merging the problem. Solution. Now, what does that mean? That is, T of n is in the form of this. Now, when T of n is, it goes to the next level, T n by b will be substituted a times. Okay. Now, this n by b will be put instead of n in this equation and the next level will be found out. Try to recollect what we had done in the iterative as well as in the recurrence tree method. Similarly, ultimately to find the value of T of n, these divided values should be all put back together, combining each and every solution to get the final answer. That is what this means. Cost of dividing the problem and cost of merging the solution. Now, f of n can also be considered as theta n raised to k log n to the power p, where k greater than or equal to 0 and p is a real number. So, f of n can also be written as theta n raised to k. You know what n is. N is the input size. K is how many times the exponential value. Log p to the base n. Log raised to p n. The Master's theorem has three cases. Okay. So, in case 1, we will find out what the value of fn is and we will put and classify into each cases. If f of n is equal to big O of n log a to the base b minus some value, minus a small sigma for some constant sigma greater than 0, then the solution for that particular type of recurrence equations using Master's theorem will be T of n is equal to theta n raised to log a to the base b. Okay, that is the first case. It can be put in another way also in terms of that k. It can be put in if a greater than b of k, then T of n is equal to theta n log a to the base b. That means a, b and k are values from these equations. A is how many times that has to divide, b is what that n is divided. This is the case. Okay. Now, case 2 is, you can understand it more when we come to examples. Now, case 2 is f of n is equal to, if f of n is equal to theta n log a to the base b log n to the power p with k greater than or equal to 0, then that is, if f of n is having, in the previous case it was n raised to some log minus sigma. Okay. Now, here there is no sigma but there is a log element also along with this. Then T of n is equal to theta n log a to the base b log n raised to p plus 1. Now, k is equal to log a raised to to the base b. Okay. Now in that you can solve it in another, putting all those k values, it can be put this way also. If a is equal to b raised to k, in the earlier case, in case 1, it was if a greater than b raised to k. Here it is taken as a equal to b raised to k. Then there are 3 conditions. If p less than minus 1, then t of n is equal to theta n log a to the base b. If p equal to minus 1, then Tn is equal to theta n log a to the base b log square n. If p greater than minus 1, then T of n is equal to theta n log a to the base b into log p plus 1 n. Okay, there are 3 different cases: p less than minus 1, equal to minus 1 and greater than 1. So if it is less than minus 1, it is just n and the log power. If it is equal to minus 1, then there is a log square n, and if it is greater than minus 1, it is log with p plus 1 power. Okay. Now the third case is if f of n is equal to omega n log, you needn't bother about omega, theta and big O. If it is time complexities of this order, you will understand when we come to the examples. If f of n is equal to omega n raised to log a to the power b plus sigma. In the first case it was minus sigma, in the second case it was no sigmas there, and in the third case it is plus sigma for some sigma greater than 0, and if a into f of n by b is less than or equal to c of f of n for some c less than 1 and all sufficiently larger n, then f of n is equal to theta f of n. Sorry, t of n is equal to theta f of n. So in this case, this can be put in this way also. If a less than b of k, in the first case it was a greater than b raised to k, in the second case it was a equal to b raised to k, and the third case is if a less than b raised to k, and if p less than 0, then t of n is equal to big O of nk. If p greater than or equal to 0, then t of n is equal to theta n raised to k log raised to p n. These are some equations which you have to go through. Keep in mind, you don't have to remember, you don't have to get disturbed with all this. You just have to remember all this. There are basically 3 cases, okay, depending upon t of n is equal to a t of n by b plus f of n. That particular f of n decides in which 3 cases your equation falls. Now we'll come to each example. So this is an interpretation. I just read the interpretation of each what we have gone through. Each of these cases can be interpreted as: first one, if the cost of solving the subproblem at each level increases by a certain factor, the value of f of n will become polynomially smaller than n log a to the base b. Thus, the time complexity is expressed by the cost of the last level, that is n log a to the base b. Okay. Next one is, if the cost of the solving the subproblem of each level is nearly equal, then the value of fn will be n log a to the base b. Thus, the time complexity will be f of n times the total number of levels. That is why there it comes, a log value also comes together. Okay. Next one is, if the cost of solving the subproblems at each level decreases by, that is minus sigma plus sigma, that is what they meant by, decreases by a certain factor, the value of f of n will become polynomially larger than n log to the base b a. Thus the time complexity is expressed in the cost of f of n. Okay. Now coming to the examples, let us brief. In brief, if f of n, all the 3 cases, if f of n is equal to O n to the power of log a to the base b minus sigma, then t of n is equal to theta n raised to log a b. You just have to conclude that. In the second case, there is a log power also with it. So, in the answer, the log will be increased by 1. And in the third case, if it is having an additional value sigma, then it is just what the f of n is. So, in brief, these are the three cases. Now, how do you substitute all this? Let us take examples with case 1. The first case is t of n is equal to 16t n by 4 plus n. Here, a is equal to 16, b is equal to 4, f of n is equal to t. That is, this is the general case. T of n is equal to a t n by b plus f of n. If this is the general case, then t of n is equal to, now from this, a is equal to 16, b is equal to 4 and f of n is equal to n. Now f of n, how will you calculate f of n? How can you say among which of these does it come into? Now you will have to find the log power. Okay, in all these cases there is a log. You have to find whether it is n log a or n log a with some log, or it is n log a minus or plus, whatever it is. So you have to find that. You know what is a, you know what is b, you just have to solve it. So how do you solve it? Log a to the base b. Okay, this is one value. This is what you have to find. Now you have to check whether this n, this is n raised to 1. So this power of value should come nearly to 1. Whether it is coming to 1 or not. How will you solve that? We will find it out. Log 16/4 is equal to a. Suppose. Then you can solve it like this. Log x to the base b is equal to y. Then b raised to the base to the power y is equal to x. That means in this case 4 raised to a is equal to 16. Now 4 raised to, what is the value of this a? It is 2. Okay. So expressing that in both cases, how will you solve this value? It is 2 raised to 2 is equal to 4. 2a, that is 2a is equal to 4. Now a is equal to 2. So log 16 to the base 4 is equal to 2. Now putting that here, in order to get n raised to 1, this value is 2. After solving this log 16 to the base 4 is 2. 2 minus or plus something will give you this n. We need n raised to 1. Okay, n raised to 1, if you need n raised to 1, this 2 should be subtracted by some value. So we can say that sigma should be 1. So 2 minus 1 is 1, you get f of n. So that means it is in case 1. That is what I have written here. F of n is equal to n raised to 2 minus 1 is equal to n, given in the equation. So it is case 1. Hence, using the master's theorem, t of n is equal to theta n log a to the base b, that is equal to theta n square. This was 2. So it is n square. You can directly substitute it. The only problem in this master's theorem is you need to find out f of n and substitute it accordingly so that you can understand in which case it is lying. Let us go for another example. Here t of n is equal to root 2 t n by 2 plus log n. So f of n in this case is log n. You need to find out how it works. A is equal to root 2, b is equal to 2, f of n is equal to log n. So the first thing what you have to do is you need to find out log a to the base b. What is this? Log root 2 to the base 2. Now how do you find this? Using this particular method, you can find out log root 2 to the base 2 is equal to a. Suppose. So after solving you get b raised to y is equal to x, 2 raised to a is equal to root 2. Okay. Now 2 raised to, so what can be this a? It can be 1 by 2. So therefore log to the base, log root 2 to the base 2 is equal to half. So it is of the value n raised to half. Put a value randomly for n, let it be 4. You can get, means just to solve. This is just to understand how you can get this. The value we took from the question, f of n is equal to log n. That is, if n is equal to 4, the log n is equal to log 4 is always a decimal number less than 1. So some sigma has to be subtracted from n log a to the base b, hence case 1. So what will be the answer? T of n is equal to theta root n. Okay. Similarly, solve it for the following. You can find out, I've just given the answers. You can find it for these many. That is, you can take this equation. The answer is this. You need to find out whether you are getting this answer or not. Okay. This is another example. T of n is equal to 3t n by 3 plus root n. The answer is T of n theta n. Just solve it and find out whether you get this value. This is another one. This is another, and this is the fifth one. Okay. Now, the same thing can be found out on another method also. This is another method. Just you can go through this. T of n is equal to root 2 t n by 2 plus log n. Okay. This is represented in this form. That is theta n log 1 n. In this n forms. N raised to 0 log n of the form this. That is, we said that f of n can also be written as theta n raised to k log n to the power p. This was also discussed earlier. So if we write this log n in this form, how do you say? It is n raised to 0. K raised to 0 means k, if it is 0, n raised to 0 is 1, and you need to get this log 1. So p's value is 1. Here a is root 2, b is 2, k is 0, p is 1. That means a is greater than b raised to k. Therefore, it is case 1. T of n is equal to theta n log root 2 to the base 2. This is equal to theta n raised to half. Okay. It can be solved that way also. Now, coming to case 2. In case 2, T of n is equal to 2t n by 2 plus n. A is equal to 2, b is equal to 2, f of n is equal to n. Solving the same method, you will find out n log 2 to the base 2 is equal to log 1. That comes to n. Therefore, it is case 2. In that, T of n is equal to theta n log 1 into log n to the power of 1. Okay. So that is the value. In the second example, T of n is equal to 4t n by 2 plus n square. A is equal to 4, b is equal to 2, f of n is equal to n square. Now n log 4 to the base 2 is equal to n square. How do you get this? How do you substitute this? This is n log a to the base b. Here a was 4, b was 2. That is how you get this. Now this is this part. It is f of n. Okay. Now when you solve this also, it is f of n. So it is, both sides are equal. So it is case 2. You just have to substitute the value. It is n square. LG means log it only. So another method, by putting those k values, you can write it in this way also. So in that case, f of n should be substituted with O of n raised to k log n to the power p. Okay. If in that case, how do you solve this? Here f of n was n square. That means O of n square log n. What was p? P should be 0. Okay. Only then this will work, because you need not want this value. Log value should be cancelled. You need only this, because your f of n is n square. Okay. So with that we can write as a is equal to 4, b is equal to 2, k is equal to 2, p is equal to 0. Here a equal to b raised to k. Therefore, and p is greater than minus 1. So what you have to do, you can just directly substitute that value. T of n is equal to theta n log 4 to the base 2 log raised to 1 n. So you get that value. Okay. Now you can solve it for these examples in both cases, in the first case as well as with the this case also. You can just check it out. When writing in the exams, you need to write only in one method. You just solve it and find out by yourself which method is easier for you. You need to find out. Okay, solve these values. This is the answer. From this you have to solve. How do you solve this? F of n should be substituted with n log n. From this you have to find out. This is of the form n log n. That means n raised to 1 log raised to 1 n. Okay, you can find out here what the value is. What is this value with this a? You have to substitute and find out. Just find it out and just intimate me. If you have any doubts, you can ask me. Okay. Now the case 3. Examples for case 3 is T of n is equal to 2t n by 2 plus n square. Here a is 2, b is 2, f of n is n square. Now solving this, n raised to log a to the base b, it is n log 2 by 2, that is n1. This comes to 1 and n raised to 1. F of n is equal to, what we have here is f of n is n square, but on the other side what we got was n raised to 1. That means along with this 1 you have to add a 1. Only then you can get this. So it is case 3. Now condition for case 3 was, you have to find that condition is a f of n by b less than or equal to c f of n for some c less than value should satisfy. For a sufficiently larger n, a f of n by b is equal to, from the equation, a was 2, b was also 2. So it is 2 f of n by 2 is equal to, now what was this? F of n is n square. So substituting that n square for n, what will you get? It is 2n square by 4. It is equal to 2n square by 2, that is, you just cancel these two and you get n square by 2. This is less than, it should be less than, this is n square. So how can you find out this value? N square, it can be written as n square and 1 by 2, n square into 1 by 2. So it is half n square. So what is c? It is 1 by 2. So the condition is satisfied for c is equal to 1 by 2. Now therefore you can write it as Tn is equal to theta f of n equal to theta n square.